Today we are checking a Delonghi Caffe Venezia. This is the control panel. It just plugs into the main board, easily removed for checking. So I'll set that aside. The first thing I want to do is see what kind of condition the brew unit is in. So I'm just going to remove that by holding it on the sides and pulling it straight forward. And there's a little bit of coffee left over, so I'll just clean it over here a little bit, like that. Now I want to find out by pushing on this part here downwards if it's easy to push or difficult. And this is, by the sound of my voice, you could probably tell it's difficult. It's not moving smoothly at all. In fact, look at how much force I have to push on it. I'll just push really hard to get it to close back. So that's a concern right there. That's in need of really is in need of replacement. We might be able to repair it by replacing the O-rings and re-lubricating it. But when it's in such rough shape like this, ideally you want to replace it if at all possible. So that's one problem that I'm finding right there. And inside, it could use a bit of a cleaning, but I'm noticing over here a bit of rust. So let's get a work light here, and I'll just try to zoom in on that a bit. I don't know if it'll focus properly, but in the back over this corner, you can see that it's rusting already. So rust in a machine like this is not a good idea, because that'll get in your drink. And the last thing you want to be doing, or one of the last things you want to do, is be drinking rust. So it would really need to be cleaned very, very thoroughly if we're going to restore it. But let's continue checking it and see the overall condition before we draw any conclusions. So I noticed that up at the top here, there's a Microswitch along with the steam valve. Again, it seems like this had a lot of use. It's very hard to turn that. I should be able to grip it with my glove and turn it, but it's not easy to turn. Okay, so that's probably going to need some new O-rings as well. Let's go ahead and clip my test leads onto the Microswitch and see if the Microswitch is going to function. I'll turn the meter onto the ohm setting. And when I push the little button over here, okay, ideally it should read all zeros on the scale. It's reading 0, 1, 2. So not real bad, but not real good either. It's had a bit of use, so it's showing its age. All right, let's move on. I'll turn the machine around, and we'll have a look here at the side. All right, again, I'm seeing a lot of rust. I'm just going to reposition the camera. Okay, here we are. We can see the side of the heater tank, and it's got a lot of calcium buildup here from where it was leaking, and the bracket that it's on is very rusted as well. So that's where the rust is coming into the inside of the machine, and potentially could get into this brew unit here, and that may be another reason why this is so difficult to move, because it's probably got rust in there as well. Okay, so we'll set that aside. It's definitely going to need a new heater tank, and the metal frame bracket needs to be replaced too. We can't use this bracket because of all of the rust. It's just not sanitary at all. Okay, here now on the back side of the machine, we see that the water was leaking from here down downwards from the water tank downwards, and then going down here. So all of this metal has got rust in different places along here and there. And this hose, it looks like it's got a lot of calcium buildup in it. So it's going to need some new hoses. And we have down here the motor. So what I'm going to do is I'm going to hook up, I have another power source for these motors that I can connect it to, and we'll just run the motor to see how it sounds. And not only are we going to listen to how it sounds, we're going to detect if there's any burning odor coming from it, because quite often when they get older, you'll smell a little bit of a burning smell. So we're going to check it for that. And I'll just get myself set up here and continue in the next video with me checking the motor. We'll link the two videos together. Alright, I have my test wires hooked up to the motor, and it's a special voltage. I'm not going to say what it is. It is written on the side. It's not line voltage, it's a DC voltage, and it's very dangerous voltage to work with, so I do not recommend anybody try this at home. It's something that only should be left for the people that are professionals that know what they're doing. So you can watch here. I'll just turn on the power and we'll see what is going to happen. Okay, that's one way. It sounded a little bit slow, and I'm just trying to smell if it smells any burning. Quite often they'll have a burning smell to them when they get old like that, especially when they're not as fast as they used to be. So I'll reverse the leads here because it's a DC motor to make it go back in the other direction. Yeah, I can smell it. It's got a burning smell to it. Yeah, they haven't invented smell-o-vision yet, so you just have to take my word for it, but it's definitely got an odor, and that's not a good sign, because this motor is what moves this part here, and because this is so stuck, it's obviously been overworking the motor, and now the motor is next to burning out. It's surprising that it never burnt out already, just by seeing how difficult this is to move. So that's not going to last much longer in that condition. Next we're going to move on to the water pump, and that'll be in part 3 of the video. Alright, now we're checking the water pump. So I got my meter set to the diode setting. Inside there is a diode built into the plastic, so we're going to check that first before we do anything else. And it's reading 566 on the meter over there. Over here you can see, there we go, 566. Okay, so that's a few digits off, but not too far off. And then if I reverse the leads and put it on the contacts, we get no reading at all. We get infinity. So the diode is working, showing a little bit of age, but nevertheless still works. So I think the pump is probably going to be in working condition, although we don't know how strong it's going to be with this test. I'm just going to see if it's got enough power to self-siphon. These are self-siphoning pumps, to take the water from this cup and pour it into this cup. So let's get this in position over here. The line there like that. And then we get another testing cord. And again, I do not recommend anybody try this at home. This is something that we do at the repair shops. but you can enjoy watching the video as I test these things. So, alright, I'm going to turn the power on, and I'm also going to draw, well, the power cord actually runs through another meter that I have that measures the amperage. So I'm going to get an idea on how much amperage it's drawing as it's running. It's drawing about 650 milliamps, and as you can see, it is pumping the water from the glass over to here. Another test we can do is a pressure test with this to see how much pressure it's capable. So I'll do that after, but first I just want to show a clipping of the amp meter that I have hooked up so we can verify that reading. So I haven't changed anything with the machine. This is my amp meter. So I'm going to turn on the pump again, and we're going to read that amperage. As you can see, it's about I would say 650 to 660 milliamps, which is reasonable for a pump like this. Mind you, that amperage could change when it's under load, when in fact it's pulling a shot of espresso and the pump is working a little bit harder. That amperage number may change. This is a video of me just removing the pump for testing outside. I'm going to test the pressure of this pump next just to see if it's going to be good to keep using. If I'm going to refurbish this machine, I need to know if that pump is going to be good to reuse. I mean, we could just put in a brand new pump and be done with it, but if we're going to try to save some cost in different parts of the machine, like if we're going to invest in a new grinder motor, then we might want to save on the replacing of the pump, for example, right? So let's just remove this. While I make it past those wires to slide this out. There we go. If it doesn't come loose like that, what I would do is use a wrench like this just to get a grip over here. There's a flat side where you can grip it, but in this case it comes loose quite easily. And there we go. I'll just set that back there for now. So let's get this in my tester. For the first time on my YouTube channel, here is the testing machine that I use for the water pumps. So let me show you how this thing works. First, what we have to do is install the pump. Sorry about the camera angle. It could be a little bit better, but it's all I basically did was I just screwed that onto there, just like that, and put the water intake there. And now I'm going to hook up my external power source. And I take my testing portafilter handle. This one simply is using a dual wall. And with the dual wall cup empty, I should get the needle to read right up to the low pressure. Once it fills with water, of course. Place the cup underneath. And here we go. So as you can see, it's going right to the line, right exactly where it should. Now that it's been on for about a minute, it went down a little bit. Now it's coming back up. So it's dropping a little bit, but then it comes back up. These pumps are designed to run for about a minute, and then they need to cool down. So after we ran it for about a minute, I'm just going to take another instrument here that checks the temperature of it, and we can see the temperature reading of the overall areas, the various areas of it. There's certain key areas that I want to measure where the coil is. I'm getting about 96 on the high temperature for where the coil is. And there's a temperature sensor that sits in the little pocket on here. It sits in right there, a little temperature sensor. So you want to measure that area. Make sure it doesn't get too hot. So by testing the pressure, it running, listening to the sound of it, and overall inspection, I think that this pump would probably last at least another 6 months, because I was noticing that it was dropping here in raising, and then if you remember earlier we checked the diode with this, and the diode looked like it was showing a bit of age. So when it fluctuates like that with these readings, and you know, the best I could say is that this will probably get maybe 7 months, somewhere around there, before it would probably need to be replaced if it's used on a regular basis. So it's more than likely a good idea to replace it now rather than to wait. Alright, next I'm going to check the circuit board and find out if it's in good condition or not by just doing a few simple tests. So I believe the board should be fine. It came in with other issues, but let's just take off all of the connectors and run a little bit of diagnosing on it as well, seeing how it's here. On these connectors, they have little push down tabs, so all I'm doing is pushing down with the screwdriver as I pull the connectors out. Not all of them are like that, but quite a lot of them are. And then on these ones, there's another tab. You just push back on that a little bit, and then they come out. These ones with the casings are a bit tricky. You have to figure out what side the tab is on. This one's underneath, so there we go, got it. This one's underneath again, this one's on the top. And I've worked on so many of these, it's easy for me to figure out where to put them back. So if you're not familiar with where they go, then you got to map them out. But in my case, it's not necessary. The reason why I have to take the circuit board out is so that I can properly test the components from the back side with my test equipment. Okay, so I got all of those connectors out, and now I just need to get a screwdriver to take the screws out. There's 5 holding in this circuit board, and there's a back lining on it as well. Now, the nice thing about these back linings is that they can show you if there's any overheating happening on the board. So get a look at that. You see where these wires connect? Anywhere there's a connection can build up a heat source because of electricity flowing through, and the amperage is the heat. So you can see here that obviously there's signs that it was getting pretty warm in there, and that's an indication that the components that are on this side of the board are getting a little bit weak from overheating. We have some capacitors of different types. We have coils and relays. We have IC chips, voltage regulators, all that fun stuff. Some diodes over here, small surface mount resistors and capacitors, and probably even some surface mount diodes in there somewhere. Yeah. So basically what I do is I just get a visual. Oh, look at that, it's even cracked. That's how hot it got. It's even got a crack in the plastic here. So that really shows that it's had a lot of use. This machine probably made somebody very happy drinking a lot of espressos over the years. So I'm going to take a reading on this capacitor here. These are the main ones that go. The first, the electrolytics, and it says on the side here that it's supposed to be 1000 microfarads at 35 volts. So instead of unsoldering it, I'm just going to test it in circuit with my capacitor meter here. I'll just set this up to the 2000 range and see if I can clip the lead on at least one side. Because it's in circuit, the reading is going to be a little bit different, but already I can tell from my experience that this is off. So the capacitors on the board would need to be changed, or the whole board itself, which is going to put the cost of repairing this way up. So overall, I say this machine has had a lot of use, a lot of wear and tear, and it's at the point now where it makes the most sense just to part it out and use whatever is salvageable or recycle. That's my best opinion and advice for a machine that comes into the shop like this. Give it an overall assessment, and then we make our decision from there. So I'm going to notify the customer, and hopefully they'll understand that not everything that comes in is ideal to fix, especially when you see rust in the machine, because we want to make sure that everyone's healthy and drinking clean espresso with no contaminants of rust in it. So there you have it, one machine that has been in service for a long time, and now it's time to retire it. Hope you learned how to diagnose the machine just by watching the video, and if you liked the video, of course, feel free to leave some comments below and give us a thumbs up.